Thank you. So this talk actually fits in really well with what Julia was talking about, so I can almost buzz through the first few slides. Thank you. So a good strategy for working with textual corpora, as you heard, is to get that raw unstructured text that's nasty and messy and hard to work with into a native R object. And looking at tidy data principles and just R in general, we like to get things into data frames. So we want to get raw text into data frames. And so what I'm going to do is talk about a way of doing this that actually builds on the tidy text package using the R package cleanNLP that I wrote. So I'm going to look at actually two different things. So I'm going to talk a lot about the data schema that I want those tidy data tables to obey, and then a little bit about the package cleanNLP and how you can use it to take the raw text and to fill out the data tables that follow this schema. So I think it's easiest to start by showing you how the cleanNLP package works because it's pretty simple, and then we'll work into the schema and show why that makes sense. So here's a short example text from James Joyce's Ulysses. I like this example, the first sentence, love loves to love love. It's fun linguistically because there are 4 mentions of the same word and they're all used differently. So if we have this object in the R object JJ, just a string, there's not much we can do with it on its own. So I'm going to use the cleanNLP package to turn that raw string into a collection of data tables. So in order to do that, I load the cleanNLP package. I have to initialize some sort of backend. So cleanNLP lets you use multiple backends to turn your raw text into data frames. So we're going to use the tokenizers backend, which is the simplest one and has no external dependencies, so it's pretty easy. It used to use the tokenizers package, which is why it's called that. It now just relies on stringy directly, but I keep the name. So we initialize that, and then I use this function run annotators. Here I'm going to give it the raw text JJ, so I have to tell run annotators that I'm passing this as a string. You can actually pass it paths, which is more efficient because it doesn't have to read all the text data into R, but here I'm just going to give it the short string. And then this runs in half a second, very quickly. And I get back this annotation object. So when I print it out in R, it just says, oh, this is a cleanNLP annotation object. It doesn't look like anything, any particular object that you know in R. And you're thinking, oh no, I have to learn a whole different language and lots of different things to work with this annotation object. But it's not true. So the annotation object is just a list of data frames. So the way I think of it is, it's basically like a data object that's a normalized set of tables that all connect to one another. So I actually wish that R had a nice multiple assignment operator so I could just pass them all that way, but it doesn't, so I have to pass back a list. So if we look at this list, every element in it is a data frame. One of them is a matrix actually, but the rest are all data frames. And they refer to the different tables in this database schema that I defined for describing the output of natural language processing. Okay, so if we look at, so any of those tables, we can pull them off with just a normal $sign operator or square bracket operator. It's actually preferable to use the getter functions that are in the cleanNLP package. So there's a get token, a get document, a get co-reference that just corresponds to all the tables. The reason that the getter functions are better is they have some options that allow you to do post-processing of the data. They also have really great help pages that tell you about all the fields in the item, so it's just easier to pull them off that way. So if we look at this table, it looks an awful lot like a tidy text object. There's one row for each token, so token, a word, or a punctuation mark. There are some fields in the beginning that tell us the ID is the document. There's only one document in this case. The SID tells me the sentence, and the TID tells me the token number. And then I have the word, and then I have a bunch of columns there that are empty. And the reason that they're empty is because I just used a tokenizers backend, and the tokenizers backend only knows how to tokenize text. It doesn't know how to fill in all those other fields. And if we looked at the other tables, most of them are currently empty. So instead, if I want to fill them in, I need to use a more sophisticated natural language processing library. So cleanNLP supports 2 of them, either Spatie, which is a Python library that's really built for speed and stability, and CoreNLP, which is built to be a cutting-edge research project out of Stanford. So you can use either of those, and all you have to do is change the part where I did init tokenizers, you change it to init Spatie or init CoreNLP. Now, of course, you have to install them yourself on your system, and that's sometimes a bit of a headache, but it's worth it because it gives you so much more information about your text. So then the object that I get back looks exactly the same set of data tables, the same columns, but this time much more of them are filled in. In fact, everything is filled in. So in addition to just the words, I now know the lemmatized forms of the words. So for example, the verb loves gets put into its infinitive form of love. I know all of the part of speech tags for all of these different tokens, and then the other tables are populated as well. So now I'm going to talk about why did I choose this data model, why these tables, why normalizing it this way. So if you look at the tidyverse packages, so dplyr, ggplot2, per, tibble, all of them, they all, well, they've become very popular for good reason, and all of them, essentially in order to use them, you have to have your data in a data frame, right? And that makes a lot of sense, and data frames are great, and that's perfect. But I think that one thing that's gotten lost in that a little bit is people who use these tidyverse packages, and I think there's this misconception that tidy data is just data that's in a data frame, and Julie was talking a little bit about this as well, that there's actually more to it than that. So if we go to Hadley Wickham's tidy data paper that actually presented this idea, he actually equates it to a database concept called the second normal form. And so the second normal form has three principles. So every variable has to be in its own column, every observation in its own row, and every type of observation in its own table. And it's that second part, or the third part, that's really important for text analysis, because we have different types of units of analysis, and they each need to be in their own table to be tidy. So the goal of the clean NLP package was to actually define this schema and to be able to take the objects, the raw objects that come out of spaCy and core NLP, and split them off into these tables. And that ends up not being trivial, because the data structures that spaCy and core NLP use are these very complex, tree-based, object-oriented objects. They're great for fitting natural language processing models. They're terrible for doing data analysis. So the package actually has R code, it has Java code, and it has Python code in order to extract off all those pieces. So now I'm just going to go through each of the tables very quickly and describe what's in them. So there's a document table. So this contains information about the document. So by default, it doesn't have much on it, but you could put additional data in there by passing it into the annotation, the run annotators function. So you can put things like the author, the date of publication, the area of location, publication, the name of the work, etc. So you can put anything that you know about the documents into this table. We already saw the tokens table, so this contains any annotation task that we know about the individual tokens. So a great example of that is the part of speech. So part of speech is an annotation that matches up to each token, so it goes in this table. Likewise, we have a table of dependencies. So dependencies are actually written on pairs of tokens. So they need their own table because the object of study is different. It's pairs of tokens, not individual tokens. So here we see there's a TID and a TID target. So it's telling you the two rows in the tokens table that the dependency is referring to. And then it's also telling you what type of dependency this is. So what's a dependency? It's essentially linking the words in a sentence to one another based on their grammatical relationships. So a canonical example would be attaching adjectives to the nouns that they describe or adverbs to the verbs that they describe. They can be very useful for doing text analysis. As I said, the one reason for using these get functions is that they have additional options that will allow the output that comes out of them to be more useful to you by default. So there's a get token option to get dependency, which merges the tokens table into this so we can actually see all of the tokens that are connected. The first sentence, every token is essentially love, so you see love written 10 times there. 6 times, I think, actually. So then there's another table called the entity table. So this describes named entities. So these are, in this case, all people. So they don't have to be people that might be known externally, but they're names of people. So Mary Kelly, Gertie McDonald, Constable 14A. In another text, they might be named locations like Australia or New York City, or a work of art like the Mona Lisa. So the named entities table captures these. And it's a different table because unlike the other two, it's a collection, an arbitrary collection of tokens. So it needs its own table. It's a different object of study. And then we have the co-references, which is probably the most experimental annotator that we have in the pipeline here. So this finds mentions of a particular entity between sentences and matches them up. So if you see the first row here, a certain person and this person, if we go back to the original text, you love a certain person, and this person loves that other person. So those are actually mentioning the same entity, right? It's just when we parse the sentence in our heads, we know that a certain person and this person are the same person, right? So the co-references are actually finding those mentions, sometimes even paragraphs apart. Finally, second to last, we have sentence-level annotations. So these are annotators that tell us something about the sentence. So the only one we currently have are sentiment scores. So the sentiment analyzer in Spatie tells me whether or not the whole sentence is positive or negative, not particular words. And then I have word vectors that, so word vectors are special. So these are mappings from words into a very high-dimensional space, a 300-dimensional space. According to tidy data framework, they should actually be in the tokens table. But it's so big and all numeric that I actually put them in its own thing so that we don't have to worry about them being in this massive data frame. But you can see they have the same number of rows as the tokens. And if you want to visualize it, it looks like something like this. And then, so sometimes, and if you were at the workshop yesterday, when we take these tokens, so the tables, they all exist and they're all linked together, and there are many ways of putting them back together. But sometimes we don't want to worry about all the different tables. We want, especially in like a teaching construct or when I'm first showing people this, I don't want to worry about all the tables and how they come together. So we have a function called getCombine that takes probably the most obvious way of pushing all the tables and puts them into one table. So the getCombine puts everything together, puts the lemmas, the part of speech tags, the relationships, the entities, everything, and puts it all into one big table. So this can be useful if you don't want to worry about the specific schema, or if you want to save the output as a particular CSV file, and you don't want to have to save it as a more abstract object. So you can do the getCombine and work pretty well with just this one object. Okay, so now I'll just show a few applications of this. So I applied the clean NLP package over a transcript, a day's worth of transcripts from CNN, the news, cable news station in the US. And so I'm just going to show a few, 3 different ways that I can understand what was going on that day on the news by parsing the text and then doing some pipes and dplyr commands on it. So here I will take all of the named entities that refer to locations or political organizations. And here we can see that something bad was happening in I'm assuming something bad was happening in North Korea, because we see North Korea at the top, we see China, and we see South Korea being mentioned a lot. There's also something going on in Turkey that day, so we get a sense of where the interesting news was happening that day. Similarly, if we look at people, this matches up with the entities that were described. So we see Donald Trump, who is going to be mentioned a lot on CNN anyway. We also see Erdogan, and we see Kim Jong-un. So that matches the Turkey and the Korea that we saw on the other table. We can also, using the dependencies, get a sense of what these particular entities were doing. So if I look at a table, I can see that the US hit something. I don't know what. We'd have to put more dependencies back together to figure that out. We can see that Korea both warned and was warning something, so that seems like something they would do. And China blasted and praised something. So what we'd ideally like to do, and it's hard to do if we had denormalized the data set, but to actually put not just 2 dependencies together, but 3 or 4 or 5, and to figure out exactly, well, who were they praising, why were they hitting someone, why were they warning someone. And then quickly, have a second. So then I can also take the named entity one that looks at locations and then hit them against a geolocation service, and then I can look throughout the day, what are the locations that people are looking at? So this is a kind of time lapse throughout the day of all the states and locations and cities. And so you see talking about the US and then talking about Korea and then going back to Turkey later in the day. So it's a neat way of visualizing a whole day's worth of news in about 30 seconds. So great. So if you'd like more information, the Clean NLP package is available on CRAN. There's also a forthcoming paper in the R journal about it that's linked from the CRAN site, and then a GitHub repository, so with vignettes attached to it. So there are many different ways to learn more about the Clean NLP package and the data model underlying it and the ways to use it, and all of several different examples of how you can do them. And then I also tweeted out this morning a link to our workshop that we did yesterday that has a much longer detailed description and tutorial of how to use the package. There we go. Thanks. Yeah, I think we have time for one question. If we have any questions. Uh-huh. Yeah, so, oh, yeah. So the question was about supporting other languages. Yeah, so the tokenizer's backend works essentially for any language that has a little trouble with Arabic and Korean, but you can set the locale of the stringy package and you'll get tokens in essentially any language. The other two, the CoreNLP and Spatie, it's just about what models they have released, and they are language specific. So CoreNLP has about 7 different languages, and Spatie at the moment has 5, but they're, especially on the Spatie side, they've come out with 2 in the last month, so they're increasing that pretty quickly. But they are language specific. Even the part of speech codes depend on the language. So, yeah, that's a great question. So, perfect.